Imagine a machine that can understand human language, respond to queries, and even write essays. Is this science fiction? Not at all. Welcome to the world of machine learning and transformers. Let's start at the beginning. What is machine learning? It's a branch of artificial intelligence that allows computers to learn from experience, much like humans do. By feeding these machines vast amounts of data, they can identify patterns, make predictions, and ultimately make decisions. It's like teaching a child to recognize a dog by showing them pictures of dogs. Over time, the child learns what a dog looks like and can identify one even without your help. That's the concept of machine learning. Now, why is machine learning important in the modern world? Well, it's all around us, often in places we least expect. When you use a search engine, machine learning algorithms are at work, providing you with the most relevant results. When you shop online, machine learning helps recommend products based on your browsing history. And when you use voice assistants like Siri or Alexa, machine learning is there too, understanding your commands and responding accordingly. But let's take a step further into the world of transformers. Unlike the name suggests, these aren't robots in disguise. Transformers in machine learning are a type of model that have completely revolutionized the field, particularly in natural language processing tasks. They've transformed the way machines understand and generate human language, making them more accurate and efficient than ever before. Transformers have been a game changer, enabling breakthroughs in machine translation, text summarization, and even in generating human-like text. All those impressive AI models you've heard about that can write poetry, answer complex questions, or even generate code, they're all powered by transformers. So how do these transformers work? That's what we're about to find out. At the heart of transformers in machine learning lies a complex yet fascinating architecture. The architecture of transformers revolves around a few key components that work together to process information. First, let's discuss the input and output layers. These are the starting and ending points for our data. The input layer is where the data enters the transformer, and the output layer is where we receive the processed information. The magic of transformers, however, really begins to unfold with the self-attention mechanism. This is the component that allows transformers to consider the entire input sequence simultaneously rather than one piece at a time. The self-attention mechanism weighs the importance of each part of the input, deciding which parts are most relevant to the task at hand. It's like having a personal guide who knows exactly what to focus on, making sure no crucial information gets overlooked. Next, we have position encoding. In traditional neural networks, the order of the input data often gets lost. But in the world of language processing, order matters. The position encoding component ensures that the transformer considers the order of the input data. It's the difference between the cat chased the mouse and the mouse chased the cat. Same words, but a different order changes the entire meaning. It's important to note that these components are not standalone entities. They work together, in layers. Imagine it as a multi-tiered cake, each layer bringing its own unique flavor, but working together to create a complete dessert. In the case of transformers, we typically have multiple identical layers stacked on top of each other. Each layer contains a self-attention mechanism and a feed-forward neural network. The data passes through each layer in turn, being transformed and refined along the way until it reaches the output layer. Understanding the architecture is just the first step. Next, we will explore how these components interact. So, we've seen the building blocks. Now, let's connect the dots and see how transformers work. Imagine a flow of information, a river of data, if you will. This river of data flows through the transformer model like water through a complex network of channels. Now, these channels are the architecture we've just talked about, remember? Each part plays a unique role in guiding the data along its journey. One of the most critical parts of this journey is the self-attention mechanism. It's like a knowledgeable guide who knows the ins and outs of the terrain and can efficiently direct the flow of data. This guide is particularly adept at handling sequential data. Instead of processing each piece of data one after the other, the self-attention mechanism can process all the data simultaneously. Quite remarkable, wouldn't you agree? This parallel processing capability is a bit like a group of experienced hikers traversing a mountain together, each one aware of the others and making progress together. They don't need to wait for one hiker to reach a point before the next one starts moving. Similarly, the self-attention mechanism doesn't need to wait to process one piece of data before moving on to the next. Now, let's add a dash of order to this journey. That's where position encoding comes in. It's the compass that maintains the sequence's order, ensuring that the data doesn't lose its way in the process. This compass guides the data, making sure it's processed in the right order, irrespective of the parallel processing. It's a bit like a conductor leading an orchestra, ensuring that each instrument plays its part at the right time, creating a beautiful symphony of data processing. It's a complex process, but the result is an efficient, flexible model that can handle a wide range of tasks. It's a complex process indeed, yet it's this complexity that makes transformers so powerful. Now you might be asking, where do we use these transformers? Well, the answer is quite fascinating. Transformers have a broad spectrum of applications in machine learning, and their versatility is nothing short of impressive. Let's begin with natural language processing, or NLP for short. NLP is a branch of artificial intelligence that deals with the interaction between computers and humans using natural language. The goal here is to enable computers to understand, interpret, and generate human language in a valuable way. Transformers have dramatically enhanced the capabilities of NLP, making it possible for machines to understand and process human language at a level that was previously unimaginable. Next up, we have machine translation, another compelling application of transformers. Machine translation is an automatic translation from one language to another. With the help of transformers, we can now translate vast amounts of text between languages with an accuracy that rivals human translators. This has opened up new avenues for communication and information exchange on a global scale. Another intriguing application of transformers is text summarization. In a world where information is abundant, sifting through lengthy articles or reports can be time-consuming. Here's where transformers come into play. They can condense these extensive texts into short summaries, capturing the main points and presenting them in a digestible format. This allows us to quickly grasp the essence of the text without having to read through it entirely. But that's not all. Transformers are also used in tasks like sentiment analysis, where they can understand and interpret the emotions conveyed in text, and in speech recognition, where they transcribe spoken language into written text. They also play a crucial role in chatbots, making them more capable of engaging in human-like conversations. In essence, transformers have revolutionized the way we approach various challenges in machine learning. They've made it possible for machines to understand and generate human language, translate text with high accuracy, summarize lengthy documents, and much more. From understanding languages to generating human-like text, the applications of transformers are truly vast and impressive. With such revolutionary capabilities, what does the future hold for transformers in machine learning? As we stand on the brink of a new era, the potential future advancements and applications of transformers are nothing short of awe-inspiring. The transformative power of transformers extends far beyond the world of machine learning and data science. They have the potential to revolutionize a plethora of fields, creating waves of change that we are only just beginning to comprehend. Let's take healthcare, for instance. With the ability to process and understand vast amounts of data, transformers could potentially predict disease outbreaks, analyze patient records for personalized treatment plans, and even assist doctors in making complex diagnoses. Imagine a world where the early detection of life-threatening diseases is no longer a challenge, but a norm. That's the promise of transformers in healthcare, but it doesn't stop there. Transformers could also redefine the way we interact with customer service. Instead of scripted responses and long wait times, transformers could provide instant, personalized assistance. Picture a customer service experience where your needs are understood and addressed in real time without having to navigate through a maze of automated responses. That's the future transformers could deliver. Moreover, the power of transformers extends beyond these applications. They could revolutionize everything from financial services, predicting market trends with uncanny accuracy, to entertainment, creating personalized content recommendations that hit the mark every time. And let's not forget about the potential for transformers to transform education, enabling personalized learning experiences tailored to each student's needs and capabilities. The possibilities are as vast as they are exciting. However, these advancements won't come without challenges. As with any technological revolution, Issues such as data privacy, security, and ethical considerations will need to be addressed. But with the right balance of innovation and responsibility, there's no limit to what transformers can achieve. The future of transformers is bright and holds immense potential. Only time will reveal what new innovations they will lead to. As we wind up, let's take a quick recap of what we've learned. We started our journey by understanding what transformers are in the realm of machine learning. These are models that use self-attention mechanisms to understand the context of a word in a sentence, making them a game changer in natural language processing. Then we dived into their architecture, which consists of an encoder to read the text and a decoder to predict the output. We uncovered how they work, using attention mechanisms to weigh the importance of different words in a sentence. We also highlighted their applications, from language translation to content recommendation and even playing a role in autonomous vehicles. Looking ahead, we pondered on the future of transformers, how they're set to revolutionize machine learning with their ability to handle complex tasks more efficiently. So here we are at the end of our journey exploring the fascinating world of transformers in machine learning. Remember, this is just the beginning. The real journey begins when you start experimenting and exploring more on your own. Until next time, keep learning, keep growing,